joining us once again. Today's show focuses on a concept we call TSMC Tesla Cybertruck or Tesla physics destroys or dominates Daimler Germany physics is our topic for today, and I think you'll find it to be quite interesting when it comes to the Tesla semi-truck. This is Greg for Teslafaninsight. Thanks once again for joining us. If this is your first time, welcome. If you're a repeat visitor, welcome back. We also want to thank our Patreon supporters. If you enjoy the show, like some ideas on investing and trading, as well as better information provided by our channel, please join us there. So, you guys may not remember this, but in 2019, there's a guy named Martin Daum. We've done a few shows about him. He is the chairman of Daimler Trucks. As you know, Daimler Trucks has been separated, or Daimler has been separated as different companies between the truck division, 500,000 Class 8 trucks plus a year, and the car division. So part of that separation actually involved Tesla. We could get into it if you'd like to, but I won't today. So one of the famous quotes from Mr. Daum is that we heard/saw the specs that Elon introduced with the truck. And our assessment is that physics in Germany and Silicon Valley are the same. So therefore, what Tesla is proposing in terms of truck capabilities of the semi are not realistic. And then he kind of went on to say that if Tesla did in fact deliver on those numbers, then we're seriously behind and we'll buy two trucks, not one, because we obviously want to go through it and see where we need to improve to be competitive. So the other part of his quote was that he would buy trucks and they could do some reverse engineering. Tesla ain't selling trucks to anybody except for pre-order customers, etc. So that did not happen as you would surmise. Sorry about the cloudy day here. I like shooting outdoors. It gives us a chance to roam around a little bit, and I can control sound, etc. So what I wanted to review today is there's something that we call TSMC physics versus Germany physics. So TSMC stands for Taiwan Semiconductor. Over the last, let's say, 6 months, I've been getting sort of briefings on how manufacturing works in semiconductors, why certain entities, i.e. Korea and Taiwan, have huge advantages, and what are the implications as we go forward. So my latest lesson focused on the fact that there's a country called China. China has been focused on building up their semiconductor industry over the last 10 years. But one of the things that's happening is that the cumulative training of the folks at TSMC / let's call it Korea allows them to deliver chips, quality, performance, etc., that nobody else in the world can. So you can buy the same equipment, but a lot of it involves the expertise of the engineers that are involved. So what they're able to do is deliver sort of chip design in ways that nobody else can really do it. And the U.S. is going to make a run at it with a $40 billion investment, and we'll see if that actually makes a difference going forward. So why do I want to discuss TSMC physics? Well, I would invite you to look at some of the video of them working. I just want to touch on a few portions of the process that's delivering these very special physics. So for example, the way things actually work is there's a company called Apple. They're the largest customer of TSMC. And the way a fab works is it's like this giant building with really expensive equipment in it. And because the building and the equipment is so expensive and the people are so expensive that nobody has enough money to be able to afford to own the whole thing and keep other people out. If anybody could do it, frankly, it would be Apple. So we're therefore in a system where you rent space in that fab. So you look at how many chips you want them to produce for you through their system. You then rent space to allow you to produce. Now, this is great because now you can use this expensive facility and you don't have to put out the buy money, only the rent money to use those facilities and people to get your chips out. So, as you may recall, one of the problems that just happened is that once those orders are in, and this could be over a year, maybe even 2 years, what will start to happen is that if you have a scheduled time for when your chips are going to be produced, then you pay, use your time in that equipment, and then you're out. Well, one of the questions that popped up was that during the pandemic, Elon and company kept using their fab space to produce chips and therefore use them in their cars. Most of the major OEMs around the world, because their margins are lower, didn't want to retain chip production space with an unknown number of vehicles that would be sold. So they actually canceled slash sold their slots. And then what happened was that all of a sudden the whole industry roared back to life after more was known about the pandemic, but it created a problem. The problem obviously was that they lost their production space in the fab. And so now they're screwed. They have all these cars they want to produce, no space on the line for fab. And that's why we had a number of cars, there are a bunch of cars in the United States where they were producing everything but chip needed portions of trucks, et cetera, at Ford and GM and others. And then over time, this is starting to, clear out, but it's still a problem in some cases. So one of the moves you have to make is, or you don't have to make it, there are chips that are sort of standard design everybody uses, and they modify them at the software level to address what their needs might be. So that way now you have a larger run. In the case of Tesla, they're intimately involved with a bunch of companies in Silicon Valley where, I wouldn't be surprised if Elon is involved in the decisions being made by the chip designer about what's going to be on the chip and not, etc. So where I see the physics of TSMC coming to play is it was explained to me that what's been happening over time is the size of the chip keeps shrinking as we go forward. Now, why is that a big deal? It could be small, it could be big. Well, it turns out that when it comes to, let's say, office equipment, they can use larger size chips because there's no space issues, and more importantly, there's no power issues related to the size of their chips per se. But what's happening is that I've had a chance to briefly look at some of what those people are doing. And in order to get to smaller and smaller chip designs, you now have things like 3D design of chips going on, etc. So now you're delivering these wow, amazing chips. But the goal really is that the smaller that chip, again, it consumes less power. There's a shorter distance for the signals to go on a smaller chip. It's faster. So it's overall a better chip, but it's smaller. So when Mr. Daum made his comments regarding the physics are different, for the size of chip that he's using, there is no difference. However, if we look at something called, there's a bunch of folks going walking. I'm in Great Falls, which is a great sort of walking area, and we'll probably step out and do a little show of what's here after we're done. So so what's happening is that there are many advantages to a shrinking chip, And it's specifically important for shrinking chips because the reduction of power use frees up that power to be used for other things within the vehicle that they're being used. So there are many ways in which Tesla, they're writing better software to drive their batteries. There's a lot of ways incrementally that Tesla wins when it comes to delivering their electric vehicles. But I would argue one of the main areas that they're winning is on chip design. And so for Mr. Daum to talk about, oh, they've got the same physics that we do, well, uh, there's a reason why Tesla is getting 600 miles of range on a semi, and the longest range Daimler truck is about 250 miles. Now, why is Tesla discussing 500 miles of range when they really can get 600? Well, it turns out, as you know, that it's a lot smarter to operate in a range between a 20% and 80% rather than going full 100 back to zero, because you end up sort of blowing through batteries faster. The, the machine, as it uses the battery, will actually alternate which batteries are being used. And so it allows, in essence, rest for those batteries as the vehicle is regularly being used. So we have this interesting situation going on then, which is not only does Tesla offer in total a 600-mile range for a truck, but they're also offering better freight weight. So Tesla is offering similar freight rate to a regular diesel truck, when in fact Daimler is offering less than half, more like 25% of the freight. So one of the shows that I plan on making very soon, and you'll see, is this whole question of Daimler has decided to deal with Tesla sort of the same way GM did once there's entry. But Tesla's, I'd say, having small problems when it comes to the semi. Number one, Tesla needs probably 3,000 of these semis at least. It might be 1,000, it might be 1,500, it might be 3,000 trucks internally. They have to move. So part of their distribution plan is, instead of putting everything on a train and having long lead times where vehicles are stored and then they're systematically moved into position, Tesla's going the route of more ordering directly of vehicles. So bottom line, they have to have speed when it gets to taking vehicles to market, and having their own trucks to move everything around is a big deal, which is how they even got started with the whole idea of doing an electric semi. Was, the pollutant capacity of the trucks is far greater than cars, as you know. So the interesting thing here is that how is our competitors doing when it comes to self-design of chips and management of their technology at a level that Tesla's at? The answer is Daimler's still offering 250 miles. And so I'll leave you for this section because we have a couple more shows in this frame to do. But there's a really interesting question that pops up. The question is this: let's say you're Daimler and you decide, oh, we'll keep Tesla out. We'll just give some free trucks away and sort of lock up the distribution space for electric vehicles, and then we're good. Well, that's kind of a good idea, but the problem is that if you only have 250 miles of range and you're running at less than half, maybe 30% of the normal freight weight of a truck, that means that your customers will be having to get, let's say, 3 trucks to equal what one Tesla Semi is capable of. So this sort of brings me to the end of sort of this discussion, and look for our next installment of this physics difference in the next 48 hours, because I think this is a huge deal that's going to really, really make a difference going forward. So one of the things that I keep noticing that's a problem here is that having a centrality of Silicon Valley, the valley operates in different ways that screw people who are long distance away. In particular, the ability of designers of all type at different companies that are working on ideas to both deal with what's currently happening and also where the whole industry is going into the future. So I just think that there's this thing happening where there's a voracious appetite for new next to help optimize on cost and other issues. And it's very difficult for outside competitors to get into this mix and win unless they're willing to commit a lot of resources and a lot of manpower to sort of stay at the leading edge, bleeding edge of this entire situation. So as a result, I don't know if you guys have noticed, but the eCascadia exists. It's the Daimler truck that they're using. Yes, it does 250 miles, but when you add the whole thing up, then the numbers are horrible. 250 miles, is really 180 because if you do, if you charge it up to 80, let it drop back to 20, and then keep doing that as the cycle, you're talking 180 miles. Now, this assumes that it's not really hot, not really cold, or you're not climbing huge mountains that suck disproportionate amount of power. So what I believe is I now understand why it is that Daimler has said they're looking to deliver a hydrogen truck first and then step into electric once they can get range that's Tesla comparable, because the numbers just don't work on the truck that they're delivering. And the one place they do have it distributed and in motion is in Southern California. As you know, the temperatures, fairly moderate there. A little bit of snow in the winter in the mountains, but in general, your average temperature is somewhere in that 50-degree year-round zone, which is actually a good operating temperature for batteries. So in theory, you don't have as many problems with range anxiety for those truckers, even if the range is actually lower. But you still have freight weight challenges that are lurking there. So we look forward to getting further into this, but overall, I just want to point out that yes, indeed, because of Tsmc and the chips that Tesla has access to that they've designed, there is difference in physics. And even the comment that physics could be different, I thought was fascinating because Mr. Daum is thinking in the terms of the chips or the trucks that they've been doing for the last 50 years, 60 years, rather than being able to clearly think relative to chips and other elements, how the next 50 years is going to look. And so this brings up the famous line in the military that says that most wars are fought with the last war's techniques. Unfortunately, Mr. Daum, welcome to the world of computers, software, and in-house chip design that's state-of-the-art. The products and services that you can deliver in that frame are completely different than what's been going on over the last 50 years. And sort of the threats to what we're going to do, the Tesla Semi and all that stuff kind of don't make sense because this isn't 50 years ago. So those techniques are going to have to be switched over to 5-micron chips, as well as other sort of new state-of-the-art techniques when it comes to technology and technology management of equipment. So next, we'd like to get over to our usual health tips. I'm actually currently in a place called Great Falls, Virginia. And why am I here? Because it's a great place for hiking, numerous hiking trails of all types here. It's also nice and quiet, so it's easier for me to get some work done. But again, from a mental and physical health standpoint, great idea to really take the time to get out there and get your 20 minutes a day walk of any type in for both mental and physical health. And also, don't forget your 25 leg lifts per leg per day with a 5-pound weight. Great idea. Thanks once again for joining us. We look forward to your comments on this. This is Greg for Teslafaninsight. Chisopwa lehitro hoda hafez draziche ni hao konbanwa. Namaste. I've got to learn Korean, but I'm still lagging on it, so I won't do that today. And in Jamaica, we say enough respect, walk good man. Thanks for joining us. Have a great day, and bye for now.